And what if I told you that right now, as you watch this video, mysterious signals are traversing the space around us, cosmic messages that the world's greatest scientists couldn't decipher? Imagine for a moment. In 1977, a radio telescope picked up a signal so powerful and inexplicable that the astronomer in charge wrote, "Wow." On the margin of the paper, 47 years later, we still don't know what it was. And that's just the first of the 7 most mysterious signals the universe has sent us, challenging all our scientific understanding. Hey there, cosmic explorers. Welcome to Cosmic Frontiers, where we transform the mysteries of the universe into fascinating journeys of discovery. Today, we're re-diving into 7 genuinely inexplicable signals that have reached us from the cosmos. From energy bursts lasting milliseconds to invisible forces moving entire galaxies. Each of these mysteries is like a piece of a cosmic puzzle we're still trying to put together. And before we embark on this expedition through the enigmas of space, I want to share that we're on an incredible journey toward 1,000 cosmic explorers subscribed to our channel. Every single one of you is part of this adventure to unravel the universe's secrets. Let's kick off our investigation with what might be the most famous and intriguing signal ever detected, the WOW signal. It was August 15, 1977, and the Big Ear radio telescope at Ohio State University was doing its normal sky sweep. Suddenly, for exactly 72 seconds, something extraordinary happened. The equipment detected a radio signal coming from the constellation Sagittarius. That was more than 30 times stronger than the normal background noise of space. To grasp the magnitude of this, imagine you're at a noisy party where everyone's talking at the same volume. Suddenly, someone shouts so loud they drown out all other voices for over a minute. That's exactly what happened in the cosmic radio spectrum. Astronomer Jerry Eman, reviewing the data a few days later, was so blown away he wrote, "Wow," on the paper's margin, and that name stuck. What makes this signal even more mysterious is its technical precision. It was detected at a frequency of 1420 MHz, which is exactly the frequency at which neutral hydrogen emits radiation. Hydrogen is the most abundant element in the universe, and any advanced civilization would know this frequency. It's as if someone intentionally chose the most universal radio channel in the cosmos to transmit a message. But here's the big mystery. We've never detected that signal again. In the decades that followed, hundreds of attempts were made to pick it up again. Using much more sophisticated equipment than the Big Ear, nothing. It's like someone sent a unique message to Earth and then just vanished. Scientists have proposed various explanations. It could have been a comet reflecting terrestrial radio signals, a natural astronomical source that experienced a unique event, or even military interference. But none of these theories can fully explain all the signal's characteristics. Now, let's jump from the past to a mystery that's happening right now, as we speak. Fast radio bursts, or FRB. Imagine cosmic fireworks that release the same amount of energy the sun produces in an entire day, all in just a few milliseconds. That's right, we're talking about energy explosions so intense they challenge our understanding of physics. The first FRB was discovered in 2007 by astronomer Duncan Lorimer, analyzing old data from the Parkes Radio Telescope in Australia. Since then, we've detected over 1,000 of these events, and each discovery only deepens the mystery. Most FRBs happen only once and never repeat, like a cosmic flash that appears out of nowhere and vanishes forever. But some, and this is even more intriguing, repeat in a seemingly random fashion. To put the scale of this energy into perspective, think of it this way. If an FRB happened at the distance of our closest star, Proxima Centauri, it would be as bright in the radio spectrum as the sun is in visible light. We're talking about events that can be detected billions of light years away, meaning the original source must be absurdly powerful. What could generate such immense energy in such a short time? Theories include neutron stars with magnetic fields trillions of times stronger than Earth's, collisions between compact objects, or even the collapse of exotic stars. But here's the kicker. When we do the math, none of these known phenomena can fully explain what we observe. It's as if the universe has an energy production mechanism we haven't discovered yet. Some FRBs show repetition patterns that suggest an artificial origin, leading to speculation about alien technology. While the scientific community is cautious about these interpretations, we can't entirely rule out the possibility that we're observing signals of advanced cosmic engineering. Now, let's journey to the icy edges of our solar system, where we find another mystery that has left scientists baffled: Pluto's heart. When the New Horizons probe flew past Pluto in 2015, it revealed something no one expected to find on such a distant and cold world: a perfectly delineated heart-shaped region on the dwarf planet's surface. This structure, officially named Tombor Regio in honor of Pluto's discoverer, Clyde Tombor, is about 1,600 kilometers wide, larger than the state of Texas. But what truly intrigues scientists isn't just its shape, but its composition and origin. The heart is primarily made of frozen nitrogen, carbon monoxide, and methane, creating a smooth, bright surface that dramatically contrasts with the rest of Pluto. To understand how weird this is, imagine finding a perfectly smooth ice rink in the middle of a rocky, irregular desert. The question is, how did this structure form, and how does it maintain itself? Pluto is over 5 billion kilometers from the Sun, receiving only 0.0006% of the sunlight that reaches Earth. Under these extreme conditions, there shouldn't be enough dynamic processes to create and maintain such an organized formation. Current theories suggest the heart might be the result of an ancient impact that created a basin which later filled with volatile ices. But computational models struggle to explain how this structure remains stable over millions of years, especially considering Pluto has a highly eccentric orbit that takes it to varying distances from the Sun. Another mysterious aspect is that the heart seems to influence Pluto's orientation in space. The concentrated mass of ice creates a gravitational imbalance that may have caused the dwarf planet to realign, keeping the heart always facing Charon, Pluto's moon. It's as if Pluto reorganized its position in space in response to this mysterious formation. Continuing our journey through cosmic mysteries, we arrive at a star that behaves so strangely it earned the nickname the most mysterious star in the galaxy. KIC 8,462,852, better known as Tabby's star, named after astronomer Tabby Tharboyagian, who first drew attention to its bizarre properties. Located about 1,470 light-years from Earth, in the constellation Cygnus, this star exhibits brightness variations that don't fit any known astronomical pattern. Imagine a light bulb that suddenly dims its luminosity by 20% for a few days, then returns to normal, and then, without any predictable pattern, dims again by different percentages. That's exactly what Tabby's star does, and no conventional explanation can account for this behavior. Normally, when a star varies its brightness, we see regular patterns caused by planets transiting in front of it, stellar activity, or stellar companions. But Tabby's star shows irregular, asymmetrical, and varying intensity dips in luminosity. Sometimes the star dims by just 1%, other times by more than 20%, a variation that would be impossible to explain by conventional planetary transits. To grasp how strange this is, consider that when Jupiter passes in front of the Sun, as seen from Earth, it blocks only about 1% of the solar light. To explain Tabby's star's brightness dips, we would need an object more than 1,000 times the size of Jupiter, larger than the star itself, which is physically impossible for a planet. Proposed explanations include clouds of disintegrating comets, extremely dense planetary rings, or even a companion star with a complex debris disk. But each of these theories faces problems when confronted with all observations. The most controversial explanation, proposed by astronomer Jason Wright, is that we might be observing evidence of an alien megastructure, something like a partially built Dyson sphere, where an advanced civilization would be collecting stellar energy, while the scientific community is cautious about interpretations involving extraterrestrial intelligence. The fact is that Tabby's star continues to defy our conventional explanations. Recent observations have shown that the star is also gradually dimming over the decades, adding another layer to the mystery. Our next mystery takes us to the first confirmed interstellar visitor to our solar system, Oumuamua. In October 2017, the Pan-STARRS telescope in Hawaii detected an object moving through the solar system on a trajectory that clearly indicated an external origin. But from the moment of its discovery, Oumuamua defied all expectations of what an interstellar asteroid or comet should be like. First, its shape. Observations indicated that Oumuamua is extremely elongated, with a length-to-width ratio of at least 5:1, possibly reaching 10:1. To visualize this, imagine a cosmic cigar approximately 400 meters long by only 40 meters wide. This is an extremely unusual shape for a natural object. Most asteroids and comets we know are relatively rounded or only slightly elongated. Second, its composition. Oumuamua showed no evidence of traditional cometary activity. There was no tail of gas or dust. We didn't detect water molecules being released, and its surface appeared to be much more reflective than that of typical comets. It was as if it were made of a different material than what we expected to find in interstellar objects. But the most intriguing aspect was its dynamic behavior. As Oumuamua moved away from the Sun, it accelerated slightly more than could be explained by gravity alone. This extra acceleration is normally seen in comets, caused by the release of gases that act like small rocket engines, but Oumuamua showed no signs of detectable gas release. Harvard astronomer Avi Loeb proposed a controversial explanation. Oumuamua could be an artificial object, possibly a solar sail of extraterrestrial origin. Its extremely elongated and flat shape would be consistent with a structure designed to capture the pressure of solar radiation. The anomalous acceleration would simply be the result of this solar sail functioning as designed. While most scientists prefer natural explanations, such as the release of invisible molecular hydrogen or a peculiar internal structure, the fact is that Oumuamua raised fundamental questions about our understanding of interstellar objects. Unfortunately, due to the speed with which it traversed the solar system, we lost the opportunity to study it in more detail. Now, let's expand our perspective to a truly cosmic scale and talk about one of the most mysterious forces in the universe, the Great Attractor. Imagine a region of space so massive that it's gravitationally pulling hundreds of thousands of galaxies, including our own Milky Way, in a cosmic dance toward a specific point in the universe. And the most intriguing part, for decades, we couldn't directly see what was causing this gigantic pull. The Great Attractor was discovered in the 1970s, when astronomers noticed that galaxies in our region of the universe weren't moving randomly according to cosmic expansion, but rather converging toward a specific area of the sky, in the direction of the Centaurus constellation. To understand the scale of this, our entire galaxy is moving at about 600 kilometers per second toward this region, a speed that could take us from Earth to the Moon in just 11 minutes. The problem is that this region is partially hidden behind the disk of our own galaxy, in an area astronomers call the zone of avoidance. The dust and stars of the Milky Way block our view, making it extremely difficult to study what's there. It's like trying to see through a dense wall of fog. We know something very big is on the other side, but we can't clearly see what it is. Later studies revealed that the Great Attractor is part of an even larger structure called the Laniakea supercluster, which contains over 100,000 galaxies spread across more than 500 million light. Our Milky Way is located at one end of this colossal structure, being inexorably pulled toward its gravitational center. But here's the real mystery. Even after decades of study, we still don't fully understand the nature of this attraction. Recent observations have shown that there might be even larger structures influencing the movement of galaxies, including something called dark flow, a collective movement of galaxies that suggests the influence of structures beyond the observable universe. This brings us to our seventh and perhaps deepest mystery, dark energy. Here we're talking about something that constitutes approximately 70% of the entire universe, but we literally don't know what it is. To put this in perspective, it's like discovering that 70% of your own body is made of something completely unknown to science. Dark energy was discovered in a totally unexpected way. In the 1990s, two teams of astronomers were studying distant supernova to measure the universe's expansion rate. Everyone expected to find that the expansion was slowing down due to the gravitational pull of all matter in the cosmos, but the results showed exactly the opposite. The universe's expansion is accelerating. Imagine throwing a ball up into the air, and instead of it slowing down due to gravity, it starts accelerating faster and faster toward the sky. That's exactly what's happening with the entire universe. Some form of energy is pushing space-time apart, causing galaxies to move away from each other more and more rapidly. What makes this even more mysterious is that this dark energy seems to be a property of empty space itself. The more space there is, the more dark energy there is. It's as if the vacuum of space is an inexhaustible source of anti-gravitational energy. But when physicists try to calculate how much energy the quantum vacuum should have, They arrive at a number that is 10 to the 120th power times greater than what S observed, the largest prediction error in the history of science. The implications are profound. Dark energy is determining the ultimate fate of the universe. If it continues to dominate, the cosmos will keep expanding and accelerating until all stars burn out, black holes evaporate, and the universe becomes a cold, empty vacuum. But it's also possible that dark energy changes its properties over time, leading to even more exotic scenarios. Some scientists propose that dark energy may not be a fundamental force, but rather evidence that our understanding of gravity is incomplete on cosmic scales. Perhaps we need a new theory of gravity, or maybe we're seeing the effects of extra dimensions of space-time that we can't directly detect. Cosmic explorers, we've just taken a journey through 7 of the deepest mysteries the universe has presented us. From the 72-second signal that still echoes through the decades, through energy explosions that defy known physics, to the invisible force shaping the destiny of the entire cosmos. Each of these mysteries reminds us of something fundamental. Despite all our scientific advancements, the universe still holds secrets that can revolutionize our understanding of reality. What fascinates me most about these mysteries is that they show us we live in a golden age of cosmic discovery. Every new telescope, every more sensitive detector, every more sophisticated theory brings us closer to answers, but also reveals new mysteries we didn't even know existed. It's as if the universe is an infinite book where every page we read leads us to even more fascinating chapters. Think about it. Right now, fast radio burst signals are passing through your body. Oumuamua is moving further and further away from our solar system, carrying its secrets, and dark energy is expanding the space between the words you're hearing now. We are part of a cosmos filled with active mysteries, not just passive observers of distant enigmas. Now I want to hear from you, our incredible community of cosmic explorers. Which of these 7 mysteries sparks your curiosity the most? Do you believe the wow signal could have been a real extraterrestrial message? Or perhaps you have your own theories about Oumuamua's true nature? Leave your thoughts in the comments. I love reading the unique perspectives you bring to these cosmic enigmas. And since we're talking about mysteries, how about helping me choose our next destination on this journey of discovery? What mystery of the universe do you want me to talk about in the next video? Black holes that violate the laws of physics, alien civilizations that might exist in underground oceans, or perhaps multiverses and parallel realities? Leave your suggestions in the comments. Your ideas always inspire our next explorations. We're on an incredible journey toward 1,000 cosmic explorers subscribed, and each of you makes this adventure even more special. If this video expanded your horizons on the mysteries of the cosmos, click subscribe and join our crew of universe discoverers. Like this video if it sparked new questions in your mind, and share it with someone else who's also fascinated by cosmic enigmas. In the next video, we're going to explore something that could completely change our perspective on life in the universe. The latest discoveries about alien intrusions on moons in our own solar system. Until then, keep looking at the stars and wondering about the mysteries they hold. The universe is full of answers waiting to be discovered, and we're going to find them together, one exploration at a time.